It's an operating systems question. We have been given 4 statements in respect to paging and we have to determine which of them is or are correct. So it is an MSQ type question. Statement 1 is saying that paging helps solve the issue of external fragmentation. Now, we understand the difference between internal fragmentation and the external fragmentation. The internal one occurs when, let us consider this is our memory. When does external fragmentation take place? When we have the space which is being wasted because of 2 different kind of structures. But when we divide this memory into equal sized chunks, let us call it, that is called as a frame. And on the other side, if we have this as a process, then that process is divided into the same size chunks and that is called as pages. The frame size is equal to the page size and every page goes and sits into one of the frames. So when this occurs, the external fragmentation gets reduced. That is because every single page is occupying one single frame. So there is no wastage of space in between. But only, let us consider, this is our page, but it is not completely occupied. It is only having, let's say it is only half filled while half of it is left empty. So only this much space will be wasted, the half of the page. Let us say the process requires 4 pages, but out of those 4 pages, the last page is only half filled. So in reality, that process is requiring just 3.5 pages, but we will give it 4 pages. So only the bottom half last page is wasted. That is called as internal fragmentation. And in this case, as we saw, there is no external fragmentation. So yes, paging does help to solve this issue because the wastage will only be between these pages, or you can say between the in a single frame, not between those frames. So yes, statement 1 is true. Next one is saying that page size has no impact on internal fragmentation. Page size does have an impact. It tries to reduce the fragmentation, but just to an extent. Internal fragmentation still persists when we are using the concept of paging. So this statement can be said to be false. Third one is paging incurs memory overheads. Now, when we divide a process into pages, then we have to maintain something, a structure called as page tables, which records which page is put into which frame. It has a page number and its corresponding frame number to indicate the mapping between these pages and the frames. So this structure has to be stored again in the memory. It is again stored into pages, so that requires some memory overhead. So the statement C is true. Last one is saying multi-level paging is necessary to support pages of different sizes. Now all the pages and all the frames are of the same size basically. But when do we incur this multi-level paging concept? It only occurs when, let us say, our process size is so large that it is divided into multiple pages. And all these pages data, their corresponding mapping would be filled into this page table. But it might so happen that this page table grew so large that it cannot be occupied in one single page. Then in those scenarios, we need to use multiple pages in order to store that particular page table itself. So that is when multi-level paging comes into the picture, and not when we have pages of different sizes. That is not correct. So this option D is false. We'll be going with just A and C.